Resume recording. Okay, so 1 more minute. So today we will see, yesterday we have seen the monitor command, right? Monitor command is separate and monitor traffic command is separate. Does anybody remember what was the difference between monitor command and monitor traffic command? Anybody? What was the basic difference between monitor command and the monitor traffic command? The monitor command, you can see what is
real-time traffic statistics.
Pardon?
Real-time traffic statistics.
No, those are done. Both are real-time traffic statistics only. But there is a small difference between monitor command and monitor traffic command. See, monitor. Yeah, anybody try now. At least.
Monitor traffic. We can see all the interfaces status, but monitor we can have a specific interface.
No. We with the monitor also we can have all the interfaces. Okay. Monitor traffic. If we say monitor, suppose monitor interface. Monitor interface traffic. Like this, if we say, it will show all the interfaces.
Yes.
But the basic. But monitor, listen to me, monitor interface traffic, it will show all the interfaces. Monitor interface gigabit 0/0/2, it will show me only gigabit interface. But the monitor interface, I say traffic, it will show me all interface. Monitor interface gigabit 0/0/2, whatever you want to say, it has become Cisco. It will show about that particular interface, and here you can say detail, you can say extensive, and blah blah blah. But at the end we saw monitor. Look at this traffic. Then you can say interface or whatever you want. This was monitor interface traffic. This is monitor traffic, then interface. What was the difference? These commands, they have shown whatever packets are coming in and going out of a particular interface. This is for exception traffic. So what is exception traffic? What was exception traffic? Exception traffic was the traffic which was going to the routing engine. Because normal traffic, it is handled by packet forwarding engine, right? It is handled by packet forwarding engine, because that is not handled by routing engine. But if a packet is coming to the router itself, maybe you are sending a ping packet to him. No, if you are sending a ping packet, it will not be handled by a routing engine, because if you send a ping packet, the reply will come from the PFE only, unless and until destination host not reachable or something is there. If we are sending a ping packet maybe from the router, if we send a packet from the routing engine, or let's say somebody is telnetting to this router, then it has to be handled by the routing engine, right? Then it has to be handled by the routing engine, and then that is called as the exception traffic. The packets which are being, a router is there, a packet is coming from this side and it will go out of this side. That will not be handled by the routing engine. That will be handled by the packet forwarding engine. That is called as the transit traffic. That is called as the transit traffic. But the packet which is coming to him, that is the exception traffic, the traffic which is handled by the routing engine. And if you want to see that, then you have to give the command monitor traffic. Okay, hope these two commands are little clear now. Now, see, the interfaces are actually showing you maybe OSPF packets or this packet, that packet, whatever is coming in or going out, you can see. And then if you, that monitor command, I mean to say, and that monitor command, if you put detail or extensive, you are actually able to see more and more details, right? Just like the debug commands you can see. But what about the whatever is going on inside the router? Whatever packets are going and coming, you can see that in the monitor command. But what is happening inside the router? How will you see that? Right? So what I'm basically saying, I hope you understand, you are understanding. I'm talking about the debug commands. Okay, I'm talking about the debug commands. So how can you see those debug commands? Right? This is where our trace point options will come into picture. Okay. So here we will see, how to do debugging with trace points. Okay. We'll see the command syntax, and we'll just see, where it is stored and what it is. Okay. So trace points are the method Juniper uses to enable the real-time debugging of the protocols. Okay, it will increase the CPU load. So, just in case of our Cisco routers also, right? So generally debugging is not allowed until and unless it's like obscure case where we are not able to solve it by any other means. Okay. And now Juniper also has understood that, see, the thing is that, first of all, whenever you enable debugging, right? Whenever you enable debugging, so it has to take out all the whatever is inside going on. And in the Cisco routers, what they do? They display it in the console. They display it in the console. And yeah, there are other options, like you can temporarily store it in the memory, right? Or you can shift it to a server, right? But primarily, if you put it in the console, the problem is that, first of all, it will be lots of CPU is taken up. Okay. Number two, depending on what kind of debugs you are doing, it may involve lots of lines, and your console will temporarily freeze, and you will not be able to, you cannot use the console till the debugs are on. Okay, like some of the big debugs I have come across are the IPsec, right? So IPsec phase 1 and phase 2, these debugs will be maybe several pages, you can say, right? It is very difficult. So normally the IPsec debugs in Cisco, I don't put it in the console. Okay, I put it in that buffer memory, right? I increase the buffer memory and put it in the buffer memory so that I can give the command show buffer, and then I can go and see it later on. Otherwise, if you put it in the console, it becomes too much. So Juniper also has realized it, and they say that we will not show it in the console. Okay, so they are telling, okay, you want to enable this, trace points. Good. You first of all create a file. Where will you store it? And then you have to tell that, okay, what you want to debug. Okay, so you have to first of all store it. First of all, you have to create a file. Okay, so then you specify one or more flags. One or more flags means what kind of debug? Let's say OSPF. In OSPF, you have to say, okay, you want to see the LSA, you want to see the hello packets or whatever. Those are called as the flags. Okay, and depending, maybe other parameters are also required. Now, so this is what, first of all, set protocols OSPF trace points file. So this is the file I have created, vmx10 ospf -debug. So this is just a name I have given, and this name will reflect, it will tell me that, oh, this file was for this debug, ospf debugs are stored here. Once it is done, you have to say set protocols OSPF trace points flag, and then you have to tell, this is just a question mark. You can see everything here, the events, OSPF events or hello packets or LSA, this, that, it's there. It is just 2-3 lines I have shown, but this is like a very extensive, you have very extensive options are there. Okay. So just to show you, I kept a debug on from yesterday in my router. Let me go there. It is in VMX1. Okay. And if you remember, the debug files, where are normally the log files? Debug files are log files. Where are they stored? They are stored in /var/log. Okay, normally they are stored here. Now, how can you see the log files? File list. File list space /var/log, and you can see that. Let us go and check. So I'm here. I'll say file list /var/log. And then this one was like whatever I have stored, whatever name is there in that PPT, right? The same name I have stored here. In fact, I have copied the command from there itself. Hold on. And okay. Okay. So I have kept it from yesterday so that I can show you this entire thing and you can understand. Now, let me tell you about some of the options which are there in the, and for that, let me go back to the PPT. Now, when you create a trace option file, the following defaults occur. The file is allowed to reach a maximum size of 128 kilobytes. I'm telling default, you can change. So each file can be of maximum of 128 kilobytes. So once the maximum size is reached, it is renamed to file name .0. A new file name is created. Okay, the number after each file name is increased as the new file name is created, and by default 10 files are created. one after another. What happens? All the 10 files get filled up. Will it stop? Will the debug stop? No. Once the 10 files are created by default, what might happen is that the oldest file will be overwritten. The oldest file will be overwritten. So let's say that your file name, what you have given, that is ABC. So everything is in default. So 128 KB is over. So this will be made ABC.0. Then the new file will be created with a ABC. This also gets filled up. So this file will become ABC.0, and this ABC.0 file will become ABC.1. Okay, then this again fills up. So this will become ABC.0. This will become .1. This will become .2. So this is what will happen, and it will go on till ABC.10. So ABC.10 is it the latest file? No, this is the oldest file, because every time a new file comes up, the file name will increase, right? This is the old file. Now again, this gets filled up. Obviously, this will be overwritten. Okay, so this is the by default. So till yesterday, I started. So you can see here some 8 files got created, and OPC 8.gz is the latest file. No, oldest file. This is the oldest file. Okay, the latest file which is currently running is this, and before that it was debug.g. Okay, so if we want now, if you want to see the file,
Shekhar, there is a
yes,
confusion on this one.
yes.
So first file will be created debug without 0.
Yeah, this file is like the current file where the debugs are coming and
After once
deposited.
this space is full, then it will create .0, then .1, .2, .3, .5, .7,
No,
and
no, no,
.8.
no. Remember the rollback? Just recall the rollback. Remember the rollback? See, what was there? There was an active configuration, right? And then there was a candidate configuration, right? When this candidate configuration is saved, he becomes the new active configuration, and this active configuration will become rollback. No, it will become rollback 1, right? Now, again, one candidate configuration, if it is saved, this will become new active configuration. And this active configuration, what will be this? Let's say this is this one. This will become rollback 1. This will become rollback 1, and this rollback while will become rollback 2. It's not that the new active configuration will become rollback 2. No, he will be the latest rollback. This is the older rollback. Earlier, this was the latest rollback. So you have the name has changed to rollback 2. Similarly, think about this. So first file is ABC. It is the current file. Everything is getting deposited here. Okay, so this is the file. So now it is full. When it is full, his name is changed to ABC.0. Okay, and a new file called ABC. Here things are getting deposited. Now, if it is getting full, so what will happen? The new file will become ABC.0, and this will become ABC.1. so that the new one will remain new. Latest one will have lower number, older ones will have the bigger number. So if this is old, means this will always remain old only. If imagine this is ABC0 and the new file becomes ABC1, then there will be little confusion, right? Because ABC1 is supposed to be the new file, but it is having a higher number. So to avoid that confusion only, they are doing this.
Okay,
Are you getting my point?
I do.
So, let's say that again, this also gets filled up. If this gets filled up, then he will become ABC0. This ABC0 will become ABC.1. This ABC1 will become ABC.2, like that. Okay.
Don't you think this is going to be take a huge time of operation by changing? If we are reaching to 10, so it is going to change the number from above all the 9. 9 will become 10, 10, 8 will become 9, 7 will become 8. So this is how it is going to be in that
this
case.
is the format they have given, but I told you this is default. Now you don't want that to happen. You can increase the size of each file. Are you getting my point? It is 128 KB. You make it 10,000. I don't know. We have to see the upper limit, but you can put it in the same file also. Okay.
Okay.
The thing is, see, if you have this kind of thing, then what happens is it becomes easier to transfer. So tomorrow, suppose to the tech support, your client wants to send it. He can send these files, right? One by one. Because see, yes, use processing is required means what are the processings? First of all, the files will be renamed. That is one problem, this one they are having. But the benefits are more than maybe whatever small extra work they are doing. So here it becomes easier, in order to look at the files. And if we are experienced enough, we will know, okay, so this command, this debug is taking this much. This file, 1 day or 1 hour worth of debug is here. Just with experience we'll come to know, right? This is having another hour. So the problem started maybe in the 3rd hour. So this we can pinpoint on this. So like that, we can, with experience, we can learn little bit more. Correct.
So this incrementing 1 by 1. So what is the maximum number where it will stop or it will be continue going on, sir?
By default, 10. I think 0. I think this is the maximum. See, 1 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 files. I think this is the maximum. And every time, hello?
Yeah, yes, sir. Yes, sir. Got it, sir. So 10, 10.
But again, it is default. You can increase this also. You say that, no, don't wait at 10. You make it something else. So then they will start putting more.
Okay.
Okay. So now this is the file list command, right? And if you want to see the file, what is the command?
List to file name.
No. That is the list. That is will show you what all is there inside a folder. What is, if you want to see a particular inside a file, what is the command?
I think show that file names. I found
File show.
Yeah.
File show. It is like file show is, what, like a cat command, but cat is for txt. Gz will not open. So whatever. So file. File show we'll have to go to that location, right? So it is /var /log / the file is vmx. Let's press tab, it will complete little part. And which one? Let's see the .8. .8.
GZ, we have to 8.gz, we have to finish it.
Then tab will work. Yeah, tab will work.
Here it is.
Okay, so you can see the debugs. I actually gave only the debug for hello, just to show you. Only for hello I have given, so it is coming up only the hello. Okay, so this is how you are using the trace options.
Okay, thank you, sir.
Yeah. Again, what I'm talking is the default options. By default, it is 128 KB. By default, there will be 10 files. Okay. Modifying trace file defaults. So that the size of each trace options file can be modified. By default, it is 128 KB. The configuration range is from 10 KB through maximum size supported on your system. So we can give the command set protocols OSPF trace options file size, and we can see what is the maximum. See, you can make it 10K. Okay. And the quantity of files created before the oldest file is overwritten can be modified. Default is 10. You can configure it from 2 to 1000, or this is actually depends on the device. So if I go to the other device, and let's try these options once. So I will go to the VCP2, and I'll just go to the configuration mode, and I'll say set it's set protocols. It is under the OSPF, right? So set protocols OSPF, and let me tell you one more thing. See, under OS protocols it is there. Then under routing options, you will find trace options. What I'm trying to say is that most of the things which are for most of the things there are trace options. See, you have trace options here, global trace option parameters, okay? Or you have set security. For security also lots of trace options are there. If under security also, if you go check, you will get lots of trace options. Here we are going for the protocols, OSPF, and under that if we check, you will see the trace options here. So trace options. Now, first thing is you have to set the file. So location, so file. So you have to give a name to the file, right? If you want to give a name to the file, I will give anything with a name of A so that it comes to in the top. Okay, just for example, A-OSPF, just for example, debugs. Space, put a question mark. So here itself you can give the size and other things, right? Default size is 128 KB, right? But if I say size, you can give those options separately also, but you can give it on single line also, right? size, you can see maximum trace file size. It can be very, very big, right? You don't want multiple files. You can make this very, very big. So if I say so 10,000, is it showing in bytes? That is the problem. So it is not telling me. So if I say $10,000, they have taken the word K, let's see. And then I can also the question mark, and there is files, maximum number of trace files, 2 to 1,000. So I'll say files, and let's say I want only, let's say, just for example, I want only 4 files, just keeping it short. Then set protocols, OSPF, trace options. Now, if you put a question mark, now get into something called as flag. This is where you will specify which trace options you want to use. Flag, put a question mark. So now you can select. Let's select event. Now here one problem is there that I cannot, like, I cannot use multiple trace flags. I cannot put multiple flags in the same line. Okay, here you can say detail or detail. Let's say detail. I have to use another line for another flag. So if I press enter, and then if I say set protocols, OSPF, trace options, flag, and then if you put a question mark and see what all other things you want to do. Maybe maybe packets. I think if you say LSA packets, then all the packets, or if you say packets, it will take all the packets, but let's say LSA update packets also. And let's commit it. Commit successfully done. Let's exit out. And then let me check the file first. File list, I know that files will get created in /var/log. And I purposefully gave the name starting with A so that it can be at the top. And I can see that it is there, right? It is there. And if I say file show /var/log/A, you can see, and I have given detail for events, so you may get some detailed information. right? Oh, it is only going 39%. Imagine how much things are moving. You want to see the latest ones? So you can say pipe last. Last will show you, I think, last couple of lines. But if you can give the number, it will show you the last that many lines. Let's say last 30. So it will show you the last 30 lines. It's not showing me. I don't think there are 30 lines here as of now, maybe. Okay, so but you can see here. And let's say I actually go and shut down some interface. First of all, I need to go and see whether any of these interfaces are connected to OSPF. If I say show OSPF interfaces, so OSPF interface is telling me 0/0, 0/1, 0/2, everything is there. So let me check. Okay, 0/1 is there, 0/0, 0/2, everything is there. So why not I shut down one of the interface? So let's say I'm shutting down 0/0/0. Okay. So I'll go to the configuration mode. Now, how do you shut down a particular interface? Anybody? How do we shut down a particular interface? Come on, guys.
Sir, disable interface name.
So disable interface name, or in the at the end you put disable. So if you say
We can use deactivate option as well, right, sir?
we can use deactivate. Deactivate we normally use in case of the protocols. Like I want to deactivate the protocols. So if I say set interface gigabit Ethernet 0/0/0, if I say disable, okay, so I'm disabling this interface. And now if I say commit, and now if I say run show OSPF interfaces, (0/0/0) is state is down, isn't it? So it's down. So now how do we go and find it in our file, right? So most probably this information will be there in the last 10 or 20, this one only. But if we see here, What was the network in that? Show configuration. Only show will do. On 0/0/0, which is like disable, it is 10.0.0.1. So 10.0.0.0/24 network, right? So can we actually find out by giving match .0.0.0. Mhm. So basically, he received the LSA update. LSA update he received. Maybe we have not given the proper exact debug. He received some update. He received some update at 4:25:44, October 28, 4:45:44, 4:45:44. So if I look here and if I say show CLI history, or 25. I don't think it will take 20 seconds, right? For 45. It is on 4:22.
Sir, is there anything you were capturing only for OSPF packets? So other logs will not record into the file.
No, it is only for OSPF, na? And I'm running OSPF here.
Then you are shutting down the interface will not capture there, right?
No, hold on. I'm shutting down this interface, okay? And this interface was running OSPF, okay?
Yes, sir.
So this network gets disabled, na? So he has to send this information to this. I'm capturing OSPF here. I'm capturing what? Log messages, debugs here. So this guy has to inform, right? 10.0.0.0 is no longer available.
Yes.
Correct. So that has to be through OSPF. So one OSPF update came. OSPF update came. Okay. This OSPF, see, there is a OSPF update, but advertisement count is 1. See, OSPF update came, but we don't know what is the detail. Maybe this LSA update, we should have put detail. Can I go and change it? So quit, configure. Oh, I'm in VMX1. Can you see that? Still, this was Telnet. I'm so sorry. I'm in VMX1 actually. This is VCP2. I didn't notice that.
You're still in VMX1.
VMX2. So if I say set protocols, sorry, I'll go to the configuration, set protocols, OSPF, and press options, file. What is the name of the file? Let's say ABCD. Okay. Demo OSPF press. And I'll say number of files, only 3. And size of each file. I want that, I want to see that file creation, right? I can make it little less. So let's say 50 KB. Okay. Okay. Then set protocols, OSPF, press options, and then you have to say what? Flags. Flags, and then what flags you want. There is a LSA update. LSA update. I would like to put it as detail. And then one more, events, detail. I think these two is fine. I don't want to do the hello packets. So once it is done, I'll just commit it. Okay. And then I'll just exit out, go to the user mode or the operation mode, and I'll say file list /var/log, and you can see demo OSPF press. Good. And then if I say file show I don't think anything will be there, but let's try. Oh. So I don't know what is this IFL and other things. Okay, but some things are going on. And so now what we will do is I'll go to the first router and enable that interface, right? Earlier I had disabled it. So it is like double disable. Like last command was this, right? So instead of set, I'll say delete. Oh, that's all. Comment. And let's go to the other side.
So, sir, like you have done no shut right now, sir. Now.
What no shut? Yeah. No shut. Yeah. See, actually, delete means no command in Cisco. Okay. One router LSA has come just now. Newer than the database. Okay. Received LSA update on this one. But still, I wanted to exactly see that particular, this one. That is from 10.0.0.0 network. I think that information comes received LS update packet from 10.0.12.1 on 224.0.0.5 area 0. Okay, anyways, so maybe, not looking at the correct OSPF, this one, correct debug. Okay, here I have given events and here I have given LSA update, these two only. But I hope you understood this. So it will be coming here. Did it get filled up? I don't think it will get filled up so quickly. File list, class var, class log. So I don't know how much time it will take to fill up, depending on how much debugs are basically getting generated. So this is what it is about the trace options. I'll just Close it. Any questions here? Anybody wants to ask anything? So basically, only two commands are required. One is to create the file, and another one is to create what all debugs you want to see. So you have this, trace options, then flag. You need to set the flags, and when you set the flag, you can say detail or brief, whatever it is. Like normally, it will be normal. If you say detail, it will have more information. One more thing is that if you want multiple flags, what you should be doing is you have to write the command multiple times. In the same line, you cannot add multiple flags. This is what we have seen. And then regarding the file size, if you want to increase or decrease the file size, this is what you
Hello.
have. Yes. Yes. Hello. Can you hear me? Hello. Can people hear me?
Yes, sir.
Yes, sir.
Yes, sir, we can
Okay,
hear you.
okay. So next is, you have the file size, and if you want to increase or decrease the file numbers, you can do that also. So this is what it is. What actually is happening on my first router, I don't know. Maybe in the first router now too many debugs are running. So let's see that. If I say file list, sorry, exit out, file list /var/log. You can see multiple files got created here. Because I kept the files as small, right? You can see that multiple, this one got created. And then here also another debug running most probably. Yes, here also this is running from yesterday, right? So I have to stop it. I'll do that later on. Now, with this topic is over, and next we will move to the routing topics. Here we will just today look at the routing table, how to interpret the routing table, and next class we'll be doing static routing, some of the options in the static routing in the next class, and then after that we'll move to OSPF. So here we'll try to learn about different types of routing table, types of routes, something called as route preference, and we'll try to understand how to interpret the routing as well as the forwarding table. So the routing table. So Juniper devices store the routes in a routing table. So routing tables are created and maintained by the routing engine. Okay. So how does the routing tables are created? Because the routing engine learns about different routes from different sources. What are those different sources? Maybe static routes, maybe directly connected, maybe because of OSPF, depends, right? So now the routing table will contain lots of information, like, he has learned a route, from where he has learned the route, right? Then when did he learn the route? How much time back he learned the route, right? All this information will be there. Now, from there, some specific information will be picked up. Specific information which is required to route a traffic. Specific information which is required to forward a traffic, only that information will be taken and they will be copied in a forwarding table. So forwarding table will contain only those specific relevant information. Okay. And one thing you should remember, that only one active route per destination is selected. Okay. In OSPF, in Cisco, if we have two routes, okay, two routes which is like equal cost and everything is same, then what happens is both will be sent to the routing table, right? Both will be there in the routing table, and it will be sent to the forwarding. But in this case, only one active route will be selected and placed in the forwarding table. Now, if you want multiple paths, if you want to do, ECMP, equal cost forwarding, okay, multipath, then in that case, there are techniques to do that. We will learn that in policies, not now. So now the routing table. Routing table where you have all the information, the routing information is there, okay, and then you have a concise version, that is the forwarding table. Okay, so what will happen is that, just look, if you look at this diagram, so you look here, this is the brain of the router. Okay, so it is maintaining a routing table, and initially from the routing table it will build a forwarding table. Okay, it will build a forwarding table, and it will copy the forwarding table into one of the PFEs, packet forwarding engines. Okay, so there can be multiple PFEs depending on the architecture, depending on the router and other things. So each one will contain is a one forwarding table. Okay, so to each of the PFEs, the forwarding table will be copied. Okay, so initially from the routing table, it will get copied to the forwarding table, which is there in the routing engine, and from there it will get copied to the packet forwarding engines forwarding table.
So in control, I think in control plane, all the routing information will be stored, but the actual forwarding will be happen in the forwarding plane, right, sir?
Yes, always it happens in the forwarding plane.
Forwarding
Okay,
plane.
only the exception traffic will come to the routing engine. Okay. Only the exception traffic. What is the exception traffic? The traffic which is meant for the router. Maybe
routing
some management traffic, right? Which one he wants to control that router, like some telnet traffic, SSH traffic, or some control plane traffic, like some OSPF packets, the hello packets, right? It is coming to the router. So those packets will go to the routing engine. Otherwise, everything is taken care by the transit traffic is taken care by the forwarding plane. So Juniper routing table. Juniper has got multiple routing table, just like other vendors. So the IPv4 routes are there in inet.0. IPv4 routes are there in inet.0, and IPv6 routes are there in inet 6.0. These are the out of this different routing tables, 90% of the time you'll be working on inet.0, or you'll be looking at IPv4 routes, and sometimes you may look at IPv6 routes. The other ones are for multicasting and other things. Okay, so you can see MPLS, multicasting, and other things. Okay, so inet.1 is for multicast forwarding. and like mpls.0 is there, inet.3 is there. Most of the times you will not be working on that, but they're separate. So when I put, if I go to one of the routers, and if I say show route, if I say show route, okay, show route. So when I say show route, you can see that it is showing me inet.0. So inet.0, these are the IPv4 networks. And then, although I don't have IPv6 networks, you can see that I have this inet 6.0. It has got two destinations. One of them is ff02::2/28. So anybody knows which address is this?
So I think that is a multicast address, FF.
Yeah. It is all routers multicast address.
Yes.
All routers multicast address, ff02::2. And anything with FE80, it's a linked local address, right? Anything with FE80 is a linked local address. So anyways, but you can see that I have this separate IPv4 and this is IPv6. Now, some of the components here in this one, you can give, if you want to see only the particular table, because imagine if you give the show route, okay, now I don't have, but in a production network, if you have MPLS, you have so many things running, it will start showing you all the tables and it will become too huge. So what you can do is you can say show route table inet. inet.0. So if you give this, it will show you only the IP version 4. Now in this IP version 4, some of the things which will tell you is, first of all, it is telling this is IPv4 routing table. It knows about the 9 destinations. There are 9 routes and 9 active. Whenever there is a asterisk, these are actives. Okay. So why you have the active? Because sometimes, you know, a particular route you may learn through OSPF, you may learn through static routing. In that case, both will be shown here. Okay. But whatever is selected best, it will show as active. That means the router is going to use this, and only that will get forwarded to the router. And then this is telling how did you learn it? It's direct. Okay. And there is a local. What is direct? What is local is, let's say you have this router, and this is like, let's say, you know, gigabit Ethernet 0/0/0/0/0. Here you have given 10.0.0.1/24, right? So 10.0.0.0/24 is the direct network. That means in our Cisco routing table, it would have shown you as connected. Okay. And then 10.0.0.1/32 is the local. That means in Cisco, this one also, they will put it as L there. Basically, they are telling that this is the local, this is the IP address on the local interface. which belongs to that network. So you have direct, you have local, you have OSPF, right? And then this one. This is the administrative distance in Cisco. Here it is called as the preference. Okay, which is like for directly connected, it is 0. For OSPF, you can see it is 10. So OSPF, they have an internal OSPF, they have an external OSPF. There we had in Cisco, we had different flags, right? For the external ones, it will be called as E1, E2, or N1, N2, right? Here, it is not like that. Here, they have separate flags itself. Sorry, they have separate preferences itself. So internal OSPF is 10. External OSPF is 150, if I'm not wrong. I have a list in the, after a couple of slides, we'll see that. Directly connected is 0, static is 5. Okay. In case of Cisco, the static was 1, directly connected was 0. In case of Juniper, it is 0, and this is 5. In case of Cisco, Juniper. In case of Cisco, OSPF was 110. In case of Juniper, OSPF is 10 and external is 150. We don't have external administrative distance in OSPF. In Cisco, in Juniper, we have it.
So why is that so, sir? Because this administrative distance is same for other vendors. Why for Juniper very specific? Because they are having their own administrative distance value.
Come up again, I didn't get you.
No. For OSPF, the routing protocols for the Cisco devices, the administrative distance value will be the different, whereas the Juniper is having different values.
First of all, ego problem, right? So everybody will keep different. Number 2, it hardly matters. Why? Because the administrative distance is totally local, right? In any way, you are not going to send the administrative distance to anybody else through any packet. Okay, so there will not be confusion.
No, actually, if the person is doing Cisco troubleshooting, when he come doing troubleshooting in Juniper, maybe he think there's some new things like administrative and router preference that will be different comparing to Cisco.
See, if they don't keep it different, then how will you come and learn? And if you don't learn, when will you take the exam? If you don't take exam, how will they get money? So many things are there, right? Isn't it? So these things are there.
So here the direct and local are both are connected, sir. Only direct is connected.
Okay. So in Cisco also it is like that. If you have worked on any router which is like 15.0 iOS or above, not 12.4. Okay, so there also you will see the routing table, something like this. Suppose I'm just drawing it. Okay, I'll just come out of this AnyDesk. So you have, let's say, router 1 connected to router 2. Okay, and then you have router 1 connected to router 2. Let's talk about Cisco. This is 0/0 interface. Here you have given the IP address 10.0.0.1/24. So in the routing table, in Cisco's routing table, what will you see? First of all, you will see connected. That is directly connected. 10.0.0.0/24 directly connected on my 0/0. It will say like this, right? And there will be a L 10.0.0.1/32 0/0. So basically it's telling that this particular network is directly connected and this particular IP address is the local IP address on that interface. Okay. Now in case of Juniper, what we see is that 10.0.0.0/24 direct on zeros. This will be, let's say, GE 0/0/0. Just for example, say GE 0/0/0 and 10 dots. Let's say this is 10.0.0.2/24. So it will be 10.0.0.2/32 is local on GE 0/0/0. Are you understanding what I'm saying?
Yes, sir. Yes, sir. Understood, sir.
Okay.
Team, I request you, like, actually, I'm also learning in Juniper. If, if in middle, anywhere I have like understood something wrong, means please correct to me so I can make a note of it.
So most of the thing is sleeping actually from last post Diwali. Okay. Anyways, so this is what
Sir, Rajgopal here. It's not. We have a back-to-back changes, sir.
I know.
We actually just listening the class, but we are not able to see the visually. But just thinking that what are the classes which no, this is my understanding point of me. I'm telling you.
Understood.
Yeah, because I thought of hardly I did not concentrate almost a week classes because there was some noise from the customer also, because we need to concentrate more on the change perspective. So that's the reason
Right.
tomorrow we have a change. We, for that we are preparing parallelly. It's not.
Understood.
Yeah, that is actually honestly speaking, this is a wrong time for me. This the Juniper class it is going on because the we have a more changes. Hardly I'm not getting time to go through it, sir.
So more changes, those those are Cisco devices or Juniper devices or
Yeah,
some other
Cisco
device.
and Juniper. Tomorrow
Both.
I have a, yeah, tomorrow it's I see actually it's something called as a, they call it as a code and template refresh code, as iOS, and as well as the complete entire configuration with respect to the new iOS version. Okay, that
Okay.
yeah, that change I have. For example, I have a five Juniper devices and three Cisco devices. So like that. So I am in a preparation like that. Many of in the team, they are also having change. That's the reason.
Understood. So if you require any assistance regarding Cisco also, you can ask me if suppose.
Yeah.
Okay.
Yeah, sure, sir. Yeah, sure. Definitely we'll come back to you. Maybe just need some time.
I know.
Thank you so much for that.
No issues. So here the different kinds of routes. This is what I was explaining. You see, uh, so whenever you put a IP address on a particular interface, you can see that there will be a direct route because he learns that okay, this IP address is in this network and that network is directly connected to me, and then there will be something called as local route, which we have just explained. So routing preference. What is routing preference? Try to understand that routing preference is what we call it as administrative distance in Cisco. Okay, so forwarding path information or the routes can be learned from a variety of ways. Juniper routers attempt to learn the best path and install this as the active route, right? So route preference values assist with this decision. Okay, so these are the integer values assigned to all path forwarding learning methods. Learning method means from where he has learned, right? So lower value is preferred. Okay, it is locally significant. That means that it doesn't matter if the Cisco router is using different administrative distances and values, and Juniper router is using different route preferences. Okay, different route preferences. So it is locally significant. So now whatever we are putting is the default one. Those things are configurable. Okay, so this is the different route preference values. The direct one is 0, static is 6. So OSPF internal route, I told you OSPF has two. One is external and internal, that is 10 and 150. Then you have this ISIS. ISIS I have done, I don't know when, I have never done in the production. Just to finish the, at that time in our routing paper, we had this ISIS, but never practice afterwards. Even I forgot. So, so this is what it is. RIP in Cisco, it is 120, it is 100 here. Okay, and then you have the BGP. BGP here, it is only 170. So earlier, as I was showing you, show route, this command will show you. This is IPv4 route. This is telling you that 10 active routes are there, right? This is the route type. It will tell you it is OSPF, it is direct, it is local. And then this one is the route preference. Okay, this is the route preference, which is the administrative distance. Now you can give a detailed information here. So if you look at this, I want you to concentrate here. So we have taken a particular router, a particular route, and we have asked for some detailed information. Show route, blah, 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 / detail, right? Now, if you look here, it is telling that it has got two entries. Two entries are there. One he has learned from OSPF and one he has learned from static. And it is telling that in front of the static, you have the asterisk. So it is the best part and it is the active part. Why it is active part? It is telling the reason here. It's telling the reason here. Inactive reason, route preference. Because the preference of OSPF is 10, preference of static is 5. Okay, here also it is telling active. Here also state is like it is not active. It is not active word is not there. Okay, so this is if you give the detail command. So from the routing table, it will go to the forwarding table, but the active routes from the routing table are only installed in the forwarding table, and packets will be forwarded based on the longest match lookup. So this I don't have to tell you. This is also in the Cisco. It is same only. First thing is that it will be packets will be forwarded based on the longest match. Now look at this routing table. This is we have to learn. So if you look at this forwarding table, the command is show forwarding table, right? Here you will see that there are two types here. There is one type here, there is one type here. Okay, now this type, it will like, it will tell you how he has learned it, okay, how it has come, and this will tell you what he is going to do with that. Okay, let's look at it. It is pretty, initially it is like confused. It is very confusing. Still, it is confusing for me. PERM means permanent. PERM means permanent, and this is getting automatically installed by the kernel when routing table was initialized. When the routing table first came up, okay, so the permanent ones are automatically installed by the kernel, okay, by the process. So there is something called as default. So what happens here is that when this will come into picture, see, if a packet has come and it is not matching any of the specific networks, if the packet is not matching any of the specific networks, then it will fall under default. Okay, when it will fall under default, what it will do? RJCT, it will reject. It will reject. It will reject, and it will send ICMP unreachable. It will send ICMP unreachable message to the source, whoever is sending. Okay. Then there is something, one more permanent, 0.0.0.0/32. When you get a packet to this, destination, it is also permanent, like, automatically set up into this one. It will also get discarded. It will also get discarded, but this will be silently discarded. Silently discarded means no ICMP message will get generated. Okay, then you see user. This user, that means this networks got installed in the routing table and came to the forwarding table because of some user process. That means maybe because of some because of some routing protocol, or because of some static routing he has learned. In this diagram, 1.1.1.0/24, it is some network beyond R2, and we are looking at R1's forwarding table. Now try to understand. This is this guy's forwarding table. So 1110/24, he has learned it through some user process. Okay. So next hop is 1131. Okay. And it is a unicast. Okay. Similarly, he is also, this one also same. Then you see 1130/24, it is telling INTF. That means it is a direct network. It is a 1.1.3.0/24. It's directly connected on this. So on 0/0/1, this is directly connected on that. That's why it is interface. And then 1130/32, I'll talk about this later on. 1131/32, it's telling destination. Okay, destination means, again, you will see whenever it is destination, it is the remote address which is directly connected to that, which is like directly connected. So what I'm trying to say here is this network is 1130/24. Now, except 1134, which is on this particular interface, except 1134, all other IP addresses are connected to this directly connected network, right? So you see 1131 1131 is a destination network, okay, which is directly reachable through this interface. That's why it is DEST, okay. But 1134 is interface. It's a local. So it is basically telling that this is the local, this IP address got installed on a particular interface because it was configured on that particular interface. Okay, so these are some of the parameters, and you can see wherever you see this word resolve, okay, wherever you see the word resolve, RSLB, so you have to resolve the next hop for that. You have to resolve the next hop for that. That's why that next hop is not there. Okay, so these are some of the things which you can learn. You can see the forwarding table and interpret. And one more thing here, this column, if you see, how many networks are using this? How many networks are presently using? So it is telling you, okay, because this is not the entire topology, right? There may be other networks also. Let's say for some network like 10.0.50.0, you have to go through this only. So I'm just telling you that how many networks are actually referencing that. It is showing you here.
Sir, here I'm having one doubt in default network. So once we execute this command like show route forwarding table, the below default and 0.0.0/32, it will be automatically display this output, or after, or we defining the default route in the particular router, it will be like this will be populated output, this one.
This default, na?
Yeah, default and 0. Because if I have some requirement that I do not want to advertise any few IPs,
These two
yeah,
are automatically there, permanent.
So if I defined any default route for any specific network, by that time, how that output will be displayed?
That will be separate. So when on Monday
Okay.
we do the static routing, I'll show you.
Okay. So by default, this default and this will be automatically, it will be like display the output if you execute the above command.
Yes. See, in the Cisco router, what happens? You tell me, if a packet is coming to the router whose destination he doesn't know, what does he do? He drop the packet, right? And then
Yeah, it will
he sends
display.
a ICMP.
Yes.
If you don't have a default route, okay,
Yes.
so you will the packet will be dropped by the router, and he will send a ICMP unreachable message, right? Same thing.
Yes.
Only thing is that in the Juniper you are able to see this. In the Cisco,
Okay.
these things are hidden.
Hidden there. Okay.
These things are hidden. In Juniper, you can see all of this.
Okay.
There
Thank
also
you,
they
sir.
drop it, right? Dropping it is reject.
Yeah, but we don't see in this Cisco environment, we don't see this
We don't
hidden.
see. Yes.
Yes.
We don't see this.
Second.
Yeah.
In the next hop, if you see the type is RSLV, means it is resolved. So there is no next hop. Can we?
RSLV means you have to. They will have to resolve it. So they will have to resolve the next hop.
Okay. Sorry, come again. Can you rephrase the statement, please?
when you say RSLB, okay, they
Okay.
have to resolve the next hop. So maybe they will look at the ARP table and they have to find out the
Okay,
next hop MAC address and send it.
Okay.
See here, already MAC address has been put. Can you see
Yes.
in the this one?
Yes. Yes.
Sir, in that case, for the resolve also, the packet will be discarded, right, sir? Because not knowing the having the next hop IP, so how the packet will be forwarded to the next? I think that also be discarded or right, sir? Or manually we have to like specify for the next hop for
No,
this
no, I
1.1.
don't think we have to manually specify for the next hop. Let's see.
Maybe in the next, if you run the command again, it will vanish from the, or it would have resolved or something. It will give the information.
So basically, I think it is pointing to the other one. So it is telling that, okay, for 1130, it has to send a packet here, right? But forwarding table should have given the information directly. I'll do some more research on this. Okay?
Okay, sir.
Yeah, we'll do some more research on this.
Thanks.
Anything else?
No, thank you, sir.
Yeah. So then we can stop today for the day. Okay, we can stop for the day. And on Monday, we are going to do the static routing. Static routing Monday, it will get over. And then we'll get into OSPF. Okay.